So now let's do an example revolving about the x-axis. So here we have the cube root of x, which looks like this. We're going to consider the x-axis and the line x equal to 8. So we're considering this region here, about the x-axis. So we're going to be integrating with respect to y. I should say y equals 8. So first I need to know my boundary points. 0, and this one right here, is going to be 2, since we know x is equal to 8. And we can easily find the cube root of 8. We do need these functions in terms of y, so I'm going to cube both sides and get y cubed equal to x. So I have 2 pi y, and in this case I consider a right and a left function. My right function will be 8. My left function is y cubed dy. So this is 2 pi times the integral from 0 to 2 of 8y minus y to the 4th dy. So I have 2 pi times 4y squared minus 1/5 y to the 5th, going between 0 and 2. So we have 4 times 2 squared minus 1/5 times 2 to the 5th minus 0. 2 times 2 is 4, times 4 is 16, minus 32/5. And then once we work this out, we get 96 pi over 5. So in summary, when we want to rotate about the x-axis, using the washer method, we'll integrate from a to b of pi f of x squared minus g of x squared dx. The shell method will integrate from c to d of 2 pi y p of y minus q of y dy. For rotating about the y-axis, the washer method will give us the integral from c to d of pi p of y squared minus q of y squared dy. The shell method is the integral from a to b of 2 pi x f of x minus g of x dx. And we'll do one last example. Here we're going to use the washer method and the shell method to see exactly what's going on. So the washer method will actually be integrating with respect to x. So we can see that we're considering the interval 0 to 1. So that tells us our bounds. And if you graph this, you'll see that f of x is on top. So we have pi f of x squared minus g of x squared dx. So we get pi from 0 to 1 of 4x squared minus 4x cubed plus x to the 4th minus x squared dx. So this is the integral from 0 to 1 of 3x squared minus 4x cubed plus x to the 4th dx. If we want to use the shell method, this time we're going to have to integrate with respect to y. So our bounds, if x is 0, g of x is still 0, and if x is 1, g of x is still 1. So our bounds stay the same. We have 2 pi y times. Well, we need to solve each of these. We can see that g of x is still going to be just y, since x is equal to y. However, this one up here is more complicated. So in particular, if y is equal to 2x minus x squared. Then we can say x squared minus 2x plus y is equal to 0. And then we can use the quadratic formula. We get 2 plus or minus the square root of 4 minus 4y all over 2, which will end up reducing to 2 plus or minus, or 1 plus or minus the square root of 1 minus y. So then we have to figure out if we want the positive or the negative here. And so you can see that this is more complicated. Sometimes the shell method will be a lot easier, and other times the washer method will be much easier.